Okay, and so this is our third and last day dealing with products and factors of polynomials for section 7.3. Now what we're going to do is we're going to divide using what's called synthetic division. It's a different way to divide, but it can be a little tricky because long division is necessary if you have something more than just like a linear term. Synthetic division is easy to do with linear terms and dividing out like an x plus 3, something along those lines. When you get to like quadratics, synthetic division, it doesn't work as well. So that's one of the main reasons why we have both methods. So one of the things that I mentioned here is that it's a more efficient form, so it is a lot easier than long division, and can only be used when the divisor is a linear binomial. So that's like x plus 4. Okay. A example of a linear binomial is x plus 4. A non-example of a linear binomial would be like x squared plus 3x plus 7. You cannot use synthetic division with this guy. Okay? So first things first, when the polynomial p is divided by x minus a, we're going to do this little remainder theorem before we start going into synthetic division. So when the polynomial p is divided by x minus a, then p of a is the remainder. This almost looks exactly like the factor theorem. But now, instead of the factor theorem, we're going to call it the remainder theorem. Whatever it's equal to is left over. And so, kind of just to put this in a weird way, but if our leftovers equals 0, then it's a factor, right? If our leftovers don't equal 0, then it's not a factor. Okay, so it tells us a few different things. First example, we're going to use synthetic division to find the indicated value. So what that means is I'm going to take this guy, I'm going to use synthetic division. I'm basically dividing by x minus 2. It's the same thing as long division. Okay? So here's what I'd like to do though. What we're actually finding is when x is equal to 2. We could do a couple of things. So when x is equal to 2, I can plug it into the equation. And so 2 squared is 4, so I'd have 2 times 4 plus 6 plus 7, and that would equal 21. Okay? Now I'm going to use this idea called synthetic division. Okay? And I just want you to see what we get, okay, and compare it. And I'm technically dividing out this x minus 2. We'll see that as we do more problems. So here's the way it works. The first thing is I put a little box. I'm going to change the color here. Put a little box up in the top left-hand corner of the problem, and whatever x is equal to is what I put in there. Then I list all the coefficients. If there's a missing coefficient, so for example, if it was like 2x squared plus 7, I'd put a 0 in for the middle guy. Draw a little line and notice how I'm creating a little bit of space down here. So your first step is I'm going to drop the first term. Okay? And these guys are going to be added. Then to get this term right here, I am going to take this 2 times this 2, and that's going to equal 4. I add these guys together, I get 7. Now I'm going to take this 7 and I'm going to multiply it with the 2 in the box. And that gives me 14 right here. I'm going to add these guys together and I get 21. This is the very last number. What I like to do here is I kind of put a box around this because I know that this very last number is what I'm looking for. And so notice these guys match. Okay? And so whether I use this process of synthetic division or whether I use it by plugging it in, either way I'm arriving at the same answer.